Okay guys, welcome to our next video. So in the previous lab we studied some new PLC software and you did some hands-on work. I gave an assignment in which you had to create some logic gates, so AND gates, OR gate, NAND gates, NOR gates and so on. And we also studied the simulator and we ran these logic gates in a simulator. In this lab we will be studying two topics. One is advanced logic gates and the second is latching circuits. So let's start off with advanced logic gates. And the question is that instead of a simple AND gate or a simple OR gate, let's say we have a circuit like this and the objective is to construct the ladder logic. So how would we do that? The first step is that you should understand what these symbols are. Like this is a NOT gate, this is an AND gate, and this is an OR gate, because this is what you must have studied, I think, in DLD, which you must have done in the third semester. So how would we make the ladder logic for this? I'll simply just copy here so that I can write. And so the first step we would do is work backwards from the output. So y is my output, and I will simply write the equation for that. So I'll simplify this by saying y is equal to C1. So let's call this C1, let's call this condition 1, let's call this condition 2, and let's call this condition 3. And this is an OR gate, so I can say that y is equal to C1 or C2 or C3. So instead of actually working with the actual each individual input, I've simplified it by calling by saying y is equal to C1 or C2 or C3, and then I can accordingly replace C1 with these inputs. I can replace C2 with this input, and that's quite simple, it's simply D, and I can replace C3 with this input over here. But for now, let's just take a look at C1, C2 and C3. And if you remember from your previous assignment, an OR gate would be represented by something like this in ladder logic. So you have your network, you have some input like this which goes to an output, and you have another input which is connected, and you could say in parallel. So that is the same logic which we will apply here, C1 or C2 or C3. And you can see that this is what I've done over here. So I've simply taken this simplified equation and made this in ladder logic. So C1 or C2 or C3, and just ignore these addresses for now, that's not very important. You should just understand that this is how we make the initial structure. And now the next step is to replace each of these conditions. So I would be replacing this condition, this condition and this condition with the actual ladder logics. So I will create a new diagram, and let's take a look at each individual individual input, starting from this one. So this was C2, and it's the simplest. So C2 is on when D is on, and that is simply equal to a normally open contact. So D is simply a normally open contact in our ladder logic circuit. So let's say this is the network. D would simply be this, and my output over here would be Y. So this is C2. Let's take a look at C3, and I'll use a different color just to differentiate. So C3 is not E, and if you remember, a NOT gate is represented by this particular symbol, So this is a normally closed contact, and because this is a OR gate, they are attached in parallel. So this is C2, D is C2, and E is equal to C3 over here. And now I can take a look at C1, and there's nothing very difficult about this. This is an AND gate, and you can see that C1 is equal to A and B and not C. So A and B and not C. So that would be a normally closed contact. So we have A dot B dot not C, and the PLC ladder logic for that is simply this. And this too would simply be connected at this particular point. So this looks a bit messy, but the idea remains the same, and in ladder logic that would simply look like this. So we have A, B and not C. So A, B, not C over here, and then we have condition number 2, which is simply D, which is over here, and the last condition, which is not E, is what I have put over here, and all of them are connected through an OR gate, which is this particular thing, and the output is simply Y. So now that we understand how to make this on paper, let's actually try doing this on the software. So I'll create a new project. I'll call this Advanced Logic, and now I can simply start. The first step I should do, if you've noticed, is that I've given names to my addresses. So A, B, C, D and E, and that is actually very useful to do, and you can simply do that by dragging your input over here, and instead of writing the address, you can simply write the name. So you can write input 1, and in this case I will simply write A. I'll press enter, and it asks me what is the associated element, so what is the address. I'll click this third button, and I will assign A or map A to x0. I'll press OK, and now I can simply use A over here, and I can also see it. And then I will simply make a OR gate. Oh whoops, I've made a small mistake. So I actually have to finish this. So I have a B and a C. So I will copy this. I'll take another input. I'll write B. I will assign this to x1. I will take another input, which is normally closed because that is what we see over here, and I will call this C, and that corresponds to x2. I'll press OK, and this is our first branch of the ladder logic. I have to make a D and an E, so I'll simply do that. So I'll take another input. I'll put D over here. I'll call this x3. I will make another branch. I'll take another input, and I will call this E, and this is equal to x4. And lastly, I'll call my output Y. I'll press enter, and let's say this is equal to Y0. So my circuit is now complete. I'll press accept. No errors, my circuit is done. I will connect my PLC. I'll write connect, and these instructions I've covered in the previous lab. So my PLC is connected. I have to make sure my simulator is in stop mode or term mode. I'll write the PLC. OK. And you can turn the simulator, and now you can simply run the circuit. So if x0 and x1 is on, that's good enough. If these two are off but D is given an input, the output would be on. And oh, I've made one small mistake. I've actually made one small mistake, that this E should be normally closed, as you can see over here. So this is how you make a simple circuit for a question like this. So I've just gone through the how to assign a nickname. I've gone through that in the actual video software. So you have two tasks. You have to do the same process, and this one is actually quite simple, shouldn't be very difficult. And give this one a try as well. Again, this is not very difficult. You have the same output and you just have different combinations of inputs over here. So you have to do these as part of your reports. Just do these and take a screenshot and add it to your reports. Okay, that was the first part of the lecture. The second part, a latching circuit. So this is a new topic. So what I will do is I'll simply close this, and since we might need a new project, let's call this latching. So let's say, for example, I have my TV and obviously I have a remote. So to turn on my TV, I press the on button of the remote. I press it once and then I release it. So that would actually look something like this. So I don't know if you can see that clearly. I'll see if I can zoom in. So let's just shift this here and zoom in. It's not high quality, but let's say that this is your, let's say this is the button and this Y0 is your the TV. So I will press the on button and my TV will turn on, but as soon as I press it and release it, Y0 will be off and my TV will be off again, right? Because there will be no power flow and the TV will go off. I hope that makes sense. So what's happening is you press this button, Y0 is on, but you obviously release the button and then Y0 is it was on and now it's off. So how do we actually resolve that problem? And this is actually what we call the latching issue. So what you simply do is you take the output and you use it as an input over here. I'll call this Y0 and treat it as a OR gate, and this is what we call latching, because what will happen is I press the button, my output is on, and now even if I release the input, if I release the button, the output is latched. So this was 0 and now it's 1, and so what will happen now is that this button will be 0, but because my output was on, this condition is true and my output will remain on. So that circuit would look simply like this. So initially my TV is off, I press a button, it turns on. When I release the button, this output becomes 0, but because my output was already on, the power will flow through this particular point of the circuit, and it will cause Y0 to remain on. So that is what we call a latching circuit. So let's actually make that diagram over here. So I will simply write x0 here, y0, and I'll connect my PLC. I'll write the code. So this is a simple on-off button. It should be obvious what will happen. So I turn on X0, I release it, Y0 turns off. Now if I latch my circuit by taking a contact, and I can use my output as an input again, I'll write my PLC again, and now let's see what happens. If I turn X0 on, Y0 is on, and even if I release this, Y0 remains on. And this is basically what we call latching, and we do this in the industry in different places for pumps and motors and so on and so forth. And oftentimes what we do is that this is latched, but let's say there's some emergency and I have to close the switch. Most industries have some emergency stop, and you can put an input for that, and that can be normally open or normally closed. It depends on you, but it's usually a good measure to add something like this, so that even if you want to stop the latching, you can do so with that particular button. So this is another example. If we take a close look, I have a start button. If I press start, and let's say my stop button is on or off, that really depends. It can be normally closed like this. Normally I see it like this, but in some cases I also see it like this, but that really depends on the industry. So if the start button is on, this motor output will be on, and it is also latched. So Y430, Y430. If the motor is on, this condition at the bottom will be true, and a lamp for power applied will be on. If the motor is off, which will happen if the stop button is turned on or turned off, this condition will be true, and I will have a separate output for no power being supplied to the lamp. So that's a basic example of latching. So you have another task over here, so it's not very difficult. Basically what you have to do is you want to start an oil pump. So you have some X0, some switch. You start an oil pump and you make sure that it's latched. So that would be something like this. This is your start button, and this would be your oil pump, and the oil pump would be latched. And once the oil pump is on, another main motor will turn on, and that will also be latched. So what will happen is that you have an oil pump, you turn it on, and then once that oil pump is on, so you'll do another check for oil pump, and that would basically be Y0. And once that oil pump is on, you activate a main motor, so that's another output, and that will also be latched. Both your pump and motor should have emergency stop buttons. Add a sensor that can shut down the pump and motor. So again, this is just another input, and add an output where if the temperature is high, so again you will be using this input, so using the temperature sensor. So this is a digital temperature sensor, so that means you can activate it by pressing some input on or off. And what would happen is that if the sensor threshold is high, that means it turns on, and then you would activate a buzzer or alarm. So this is another output. So it's quite simple. Go through this. It's a very basic understanding of an industrial process, and it should not be difficult. So label your inputs and outputs. You can choose whatever addresses you have, and this is due by next week's lab, so 19th of May. So on that, for that report, you have this particular task, and you also have these two logic gates. So that's it for this video. Again, if you have any questions, just feel free to ask me on the group on WhatsApp or on the Google Classrooms page.